Okay, well, next question involved the graph of f of x equals 1 over x minus your a value. We want to graph this using transformations. Now, we just did the section of transformations. We've been talking about transformations for 2 weeks. That's simply because I find the transformations are difficult. You know how to move points. You should know how that correlates to the expression for a function, how given motion correlates. So this will be 1 over x minus the value of a. In my case, that would be 1 over x minus 4. And we should recognize that, as I said, using transformations of the basic reciprocal function. So you know that this is going to have something to do with the basic reciprocal function. You know that the basic reciprocal function is 1 over x, even though what the graph of the basic reciprocal function looks like. I mean, you need to know this at this point. And you need to know it through the whole course because it keeps coming up. All the basic functions come up again and again in the course. Okay, so you have to know then, how's the graph of 1 over x minus 4 related to the graph of the basic reciprocal function? Okay, well, if f of x equals 1 over x is your basic reciprocal function, then 1 over x minus 4 is f of x minus 4. Because you plug in x minus 4 in here, you get an x minus 4 for x. You get 1 over x minus 4. And also, for any function, f of x minus 4 is horizontally shifted 4 units to the right of f of x. This is because if you do f of x minus 4, well, I'm not even going to say it. Go back to what we did. It's because the graph of f of x is 4 units behind the graph of f of x minus 4. The graph of x minus 4 is not 4 units behind the graph of f of x. Again, review the videos, review my explanation, review your notes if you have them. Try to understand why this is the case. We worked it out in a fair amount of detail. Whether you understand it or not, you have to know this. Okay? You have to note the graph of f of x minus h is horizontally shifted h units from the graph of f of x. And since that was the assignment for last class, previous class 2 days ago, it's reasonable to expect that we would know that. However, this is 3 things to put together. So even if you know that, you might lose it in the complexity of the problem. Okay? Make sure you understand it now, though. Okay, so you got the horizontal shift of plus 4 units, meaning you take your reciprocal function, which has this graph, and shift every point 4 units to the right, which will give you the purple graph. Also, you've got to get an asymptote at the y-axis. The y-axis is an axis of some kind of symmetry here, okay? You actually have a reflection through the origin, but we're not going to talk about that yet. But the y-axis is kind of significant, and it helps you see where these things are supposed to be. So it doesn't hurt to put a dotted line here through x equals 4, where you've shifted the y-axis 4 units to the right, along with the graph, and see how that relates. It's like you got a new y-axis 4 units to the right, and there's your basic reciprocal function. But on the original set of coordinate axes, this coordinate is 4, and these coordinates are 4 greater than the x coordinates of these points. So you were asked then, well, you were asked to graph using transformations. That doesn't mean you write down a table and plug in numbers. We don't graph that way. The only thing that we graph that way, normally, unless we have a big exception, the only thing we graph that way is the basic functions at the basic values. Everything else is transformations. And we really have to understand that, and we really have to get used to it. Okay, well anyhow, there it is. Okay? That's how we graph using transformations. Now I'll just extend this just a little bit, just to put things in a little more perspective. And I don't know what's happened on my colored chalk, I just hit it with one of these boards. And I do need to keep this board here. So let me pick this. Okay, if I said 1 over x minus 4, well, actually we did. And I didn't label it, but I did it in yellow chalk, so let's do it with yellow chalk. It's been a day since we did this, and I kind of lost track of what I've done. But we've got this yellow graph, okay? And what's that yellow graph? The reason the yellow graph is there is that some people, and it's a fairly natural mistake to make, didn't distinguish between f of x minus 4 for the reciprocal function, which is, of course, 1 over x minus 4, and f of x minus 4, okay, which would be the reciprocal function but the y value for given x would be 4 less. Now if the y value, for example, when x equals 2, 1 over x is 1/2, so you have the point 2 1/2. Now if you do 1/2 minus 4, you have negative 3.5. That's 4 units below this. I didn't want to go down here because I knew I'd need this stuff, this part of the board. So instead, I went up just to demonstrate the difference between a vertical and a horizontal shift. F of x minus 4 equals 1 over x minus 4 would be down here, 4 units below the graph of your basic reciprocal function. What I've graphed here is f of x plus 4. So if it's f of x plus 4, that means every point here goes up 4 units because the y value will always be 4 or greater. So if x is negative 1/2, the y value of f of x would be negative 2. If x is negative 1/2, the y value is negative 2. So f of negative 1/2 would be negative 2. F of x plus 4 would have value negative 2 plus 4. So the y value, instead of being negative 2, would be negative 2 plus 4, which is 2 units above. Of course, that gives you 2. So every point of the graph of f of x gets raised 4 units to give you the graph of f of x plus 4. F of x, function f of x plus 4. That's not f of quantity x plus 4, and you really need to look again, if you're not clear on this, at the material on transformations. Read the textbook, look at videos, look at the open math videos, whatever it takes. You need to understand these transformations because that's where almost all of our functions are going to come from. Okay, absolutely essential picture. Okay, well, the other thing I wanted you to do here, to really kind of nail inverse functions, was find the formula for f inverse of x. Okay, I said find the formula in graph using transformations. Well, f inverse of x is what? Okay, since y equals f of x equals 1 over x minus 4, we have y equals 1 over x minus 4. For the function f of x, for the inverse function is gotten how? We switch the x and the y values on the table. we switch the x and the y coordinates on the graph. We could very quickly switch x and y coordinates and get our graph. Okay? Well, what we do is, to get the formula for f inverse, we switch the x and the y in this formula so that the y becomes x and the x becomes y, and then we solve for y. And I solved this in some detail. X times the quantity, well, okay, we have x equals 1 over y minus 4, solve for y. We multiply both sides by the denominator, y minus 4. Almost always when we have an equation that has denominators, we multiply by denominators until we've cleared out all the denominators. We don't want denominators. Okay, so we have x times the quantity y minus 4, multiplying the left side by y minus 4. That equals 1 over y minus 4 multiplied by y minus 4. Since this is a fraction, I'm going to write y minus 4 as y minus 4 over 1 so we can keep numerator and denominator straight. And then this, of course, equals, in turn, multiplying numerators, 1 times y minus 4 is y minus 4. Y minus 4 times 1 is y minus 4. So we have y minus 4 over y minus 4. Dividing a quantity by itself gives us 1. So that x times y minus 4 equals 1. Now we're trying to solve for y. Not thinking about what I was doing. In class I went ahead and solved for x, because you usually solve for x. So I solved for x, and of course I got back here and that didn't help. So then I had to erase what I had down here, so it's a little sloppy. But you have x times y minus 4 equals 1, and you got to solve for y. It's really easy to solve for x, but we've already been there. Okay, solve for y. Well, means you're going to have to divide both sides by x to start with. So you have x times y minus 4 divided by x equals 1 over x. X divided by x is just 1, so you have y minus 4 equals 1 over x. So y equals 1 over x plus 4. And that's why I graphed f of x plus 4, which is, of course, 1 over x plus 4. So here's the graph of f inverse of x. Now there's a property of the graph that I'll just mention right now. And I didn't notice that it was very much emphasized in the open math. But I draw a line representing the equation y equals x. And if I have equal scales on my x and y axis, which I don't, then if I reflect this thing, turn it around, and reflect it across this line, I get this. And that's plausible. If I turn this around and then move it an equal distance on the other side of the y equals x line, it's plausible that we would get this. And if I do the same thing here, turn it around, it's not going to change its shape much the way I've drawn it, it really should. But you turn this around, move it down here, and there it is. Okay? So that reflecting these two across the y equals x line gives us these two. And there's a simple reason for that, but I'm not going to go into it. Now the last thing is we want to verify that f of f inverse of x equals x, because that's the condition for an inverse function. So once we've got our expression for the inverse function, we plug it in to the expression f of f inverse of x and see if it comes out x. And we also plug it into, as you should know from the homework, into f inverse of f of x. And it should also equal x. I've only done this one, I only asked you for this one because it was don't want to take up too much class time. So f of f inverse of x, well, f of x, again, is 1 over x minus 4. So f of f inverse of x, replacing x by f inverse of x, is this. And I did emphasize in class, and I've got to continue to emphasize because people aren't doing it. Don't skip this step. If you got f of f inverse of x, put the expression f inverse of x, literally, here where x was. And then go on, because otherwise you're trying to do 2 steps at once, and everybody's confusing it. Almost everybody is confusing it frequently. Okay? So we put the f inverse of x here. And then we put the expression for f inverse of x, which we obtained here, 1 over x plus 4. So there's your 1 over x plus 4. Then you have your minus 4, of course, from the original part of the function. Then something got smudged here, so let's fix it. Okay? 1 over x plus 4 is a quantity that you can express with common denominator x, because that's what you have to do to add fractions. So here's a fraction that we have to add. The fraction involves a denominator. It's not a number, it's a symbol, but it's the same thing. To put 4 over the denominator x, we multiply 4 by x over x. And we get 4x over x. Think 4 over 1 times x over x. 4 times x, 1 times x. Gives us 4x over x. I didn't have room to write this out in detail, and that's what we do. And of course that equals them. We can add the numerators. We have denominator x, 1 plus 4x over x. We still have a minus 4 here, so we got to write that as 4x over x and add it. I didn't have room to do both steps, but we get 1 plus 4x minus 4x over x here. And 4x minus 4x is 0. So we get 1 over x. And 1 over x is 1 times x over 1, because that's how we divide fractions. It's 1 divided by 1 over x, and that's just x. So there it is. We showed that f of f inverse of x equals x. Now if you made a mistake in the algebra here, or if you got something else for your inverse function and plugged it in, it wouldn't work out. Now the algebra here is a little bit complicated, but this is just basic intermediate algebra. Prerequisite for this course, okay? So you want to ponder that, and if you need to upgrade your intermediate algebra, it's easier to do it before you encounter it in this course. You might want to look at the videos that I've put onto your web page, your Canvas page, the videos from the support course MDE 61 for this course, or even the intermediate algebra course, although we haven't gotten in the intermediate algebra course to doing things quite as complicated. So just a little advice there.